wonderful for target practice. Very good for target practice. And that's why we actually brought a second one here. So we'll use this one as well. And we need our launcher again. And then we need our lighter again. And then all we need to do is find the target. Okay. Find the target. Put this in here. Will this go? Oh my God! It should go. It should be fine. Over there? Okay. Alright. Okay, I'll angle it like that. 3, 2, 1, and fire. Ignition! Anybody hurt? Okay. These are the bottle rockets. So how do these things work? You tell me. No, you guys, you shut up. Anybody else? Yeah? Alcohol. Okay. Well, we had alcohol in the other demos too, and we just ignite it and it burns a little bit. It doesn't go like. Huh? There was something else in there? What else was in there? Magic! Magic! Yeah, that's it, exactly. Okay, we'll leave it at that, okay? Okay, it was pure oxygen in there. Pure oxygen plus methanol. And which is interesting because the first rockets that were ever built were actually based on a alcohol liquid oxygen mixture as well. But, okay, so we're almost at the end of our show. We do have some more explosive demos here. Yay! And why don't we do those? Okay. Okay, so for this we need this, and we will need the lighter, which is here. Okay. So do the other ones first. We have here. Okay. All right, Eric is going to tell you how you can really get your party started. So
we got some balloons here, and everybody knows that's the key to a banging party. So I want everybody right in this area to really cover your ears. Like, you're gonna have to watch out. These yellow ones, these are for kids' parties. They're fun, but you know, not quite as big. That's pure hydrogen inside there. And let's try that again. That's how you have some fun.
All right.
But let's see what.
So these are about 10 times louder than that. Okay. So really plug your ears.
Ah! How about again? Yeah? Give me a countdown. 3, 2, 1.
What was in the blue balloon?
Okay. So, the last thing we want to show you today is some really cool stuff, okay? So, we'll take a big styrofoam container for that. Mohammed is going to pour some of this liquid in there, which is, does anybody know? Liquid nitrogen, right, it's not water, no. It's liquid nitrogen, which is basically compressed air and cooled air. It's about minus 200 degrees Celsius.
show you how cold this is. This is a banana, piece of wood.
Just throw it in there. Just throw it in there. Okay. Takes about 2 minutes. Do we have some hose or something to destroy?
We're gonna nail these.
Yeah, we need the hose first. The banana takes 2 minutes. Okay. So when you put things into liquid nitrogen, they get really cold. They get minus 200 degrees Celsius cold, and then they will change their properties quite a bit. So what Mohammed just put in there is a plastic hose. We have lots of those plastic hoses in the lab because we need to funnel water around and gases around. So we use them quite often. And so that plastic hose probably should be cold by now. So take it out. So is it different? No, you can't nail it. Give me that thing. Okay? So this is that frozen plastic hose. So what I'm going to do is I'm going to smash it. Okay? I'm going to smash it. 1, 2, 3. What happened? The frozen parts are still pretty cold and rigid, but the warm parts are floppy. Yeah. So, but does anybody have an idea why this stuff becomes so brittle when it gets cold? Or what is rubber anyway? Does anybody know what rubber is?
Polymer.
Polymer. It's polymer. It's like spaghettis. Lots of spaghettis, all curled together. But when we bend the hose, the spaghettis they can still move around a little bit, and that's why the whole rubber is flexible. But when we cool it, then we basically glue the spaghetti to each other, and then they cannot move around anymore, and then they become brittle just like that. All right.
Is banana ready?
So, well, it's still boiling. You see when it's still boiling like that? So normally we do also some flowers. You can really cool flowers and they become brittle like glass a little bit, but we didn't bring any. Also it's always a mess to do it, okay? So what we're going to show you is what you can do to this banana. And let me see, why don't you get the tongs and then you can pull it out in maybe 10 seconds or something like that. So this looks a little bit like a deep fryer here. It's like we have French fries in there, but except that it's a big banana. So, alright.
Alright, so this is so hard, I'm gonna nail this wood.
So we got a pretty brittle banana. It's brittle, alright. Alright, thank you, Mohammed.
That's not cool. That's not cool. What'd you guys say about not putting your hand in here? Something about that? Yeah. How cold is this, guys?
Hey.
Don't worry about it, Professor.
Hey, what are you doing?
I've been training for this. It was about... Wow. It's negative 320. It's okay.
What is he doing?
So, I just wanted to show you guys. Oh, God. It's starting to get really numb. I don't even feel it anymore. Have you guys ever seen someone do this before?
Yeah.
You have? What kind of friends do you have?
I have nothing to do with this.
You guys saw what happened to the banana, right?
About 10 more seconds and I think my whole hand's going to fall off. But I want to prove to you guys that my hand's in there. So, I brought a hammer. Alright guys. In the name of science.
Okay, with that impression, we'll let you go for today, okay? Thank you all, and please come over. This is Davis Chemistry Club. All right. Well, I hope you enjoyed the show. maybe you'll be back next year for picnic day.
Alright, guys, there's ice cream out on the road by the ice cream.